Hey everybody, welcome to today's video in Helius's Solana Frontend Developer course. Today, you're going to use Helius's Compressed Mint NFT API and Helius's DAS API to create a Compressed NFT Minter. My name is Nathan Galindo. I'm a developer experience engineer at Helius. I'm based in Texas and I'm a full stack Solana developer, so please feel free to reach out to me on X to ask me any questions about Helius, this course, or Solana. Today, we're going to have an overview of the project we're going to build, and then I'm going to teach you a thing or two about how NFTs are represented on Solana, and specifically how compressed NFTs are represented on Solana. And then we're going to go ahead and build the project out together. Okay, so before we dive into the code, I want to actually take a second and explain what compressed NFTs are on Solana. So if you're new to Solana or you just have never heard of compressed NFTs, essentially, they allow us to mint bulk amounts of NFTs at scale. And I mean like to the tunes of hundreds of thousands, millions, or even like a billion NFTs for a drastically reduced cost, right? So if you wanted to mint, say, 1 million NFTs on the Polygon network or on Ethereum, that would probably cost you like millions of US dollars. I'm not even kidding. Or at least like hundreds of thousands of US dollars. It would basically cost you a fortune, like an actual fortune. But using compressed NFTs on Solana, you could mint that same amount of NFTs, so 1 million NFTs, for maybe a few $1,000s, maybe even less. So comparatively, the cost of minting mass amounts of compressed NFTs is significantly lower than of minting normal NFTs on Solana and especially on other blockchains. But what's the catch, right? How do compressed NFTs work? Why is it so cheap? Well, it's actually a kind of a relatively simple idea. We essentially, and you can see this here in the text that I provided you, this document will be available to you in the description, by the way, if you want to reference it on your own. We take the bulk NFT data, so that metadata of the NFT, and we store it on the Solana ledger instead of on chain. And this means that, we get access to cheaper storage, right? And so we take a fingerprint, a digital fingerprint or a hash of that NFT data, and we store it in a Merkle tree, okay? So what's a Merkle tree? Well, here's a simple visualization of a Merkle tree that I have for you, and if you click on this link, it'll take you to a helpful Helius article that explains these concepts in more detail. But essentially, using a Merkle tree, we're able to store these fingerprints of this compressed NFT data in an agglomerative tree structure. There's an SAT word for you. That essentially, here, as you can see here, so each leaf node, let me explain like this. Each leaf node is a compressed NFT, right? So we have 1, 2, 3, 4 compressed NFTs in this Merkle tree. And then we, agglomeratively hash each hash until we get to a root node. And that root node, that root hash at the very top of our Merkle tree is what's stored on chain. And so this approach enables us to aggregate multiple NFTs like you see here into a single Merkle root, which you see up here, that we store on chain. And this on-chain root ensures that the program interactions are valid and secure. Why? Because by taking a fingerprint of this NFT data, we're able to validate whether that NFT data that we store off-chain has been tampered with or not, right? Because if it's been changed since the moment we took that fingerprint, then the fingerprint of that changed data isn't going to match the fingerprint of the original data that we initially hashed, essentially. And so here's some key aspects that you can look over here of, the benefits of and the ins and outs of storing compressed NFT data. So the process of our code, essentially, it's going to look something like this. We have our client, that's what we're building, our client code. and we're going to interact with the Helius Mint API, which is going to abstract a lot of the, just logic away from us and relay our request to mint an API to the Bubblegum program on chain, right? And the Bubblegum program is essentially uses the compression program, the Solana compression program, to create a Merkle tree and store each compressed NFT in that Merkle tree, essentially. And here's some more descriptive text that describes that process for you. But just to go over it one more time, we are creating the client. This is us. We are going to use the Helius Mint API, which is going to relay our request, abstracting some of that business logic away from us, to interact with the Bubblegum program on chain, which then creates our Mint API, our compressed NFT on the Solana blockchain, like so. Okay, so I hope this high-level overview of compressed NFTs made some sense. Again, please feel free to reference this Helius article to refine your idea of what compressed NFTs are and how they work. And there are also other materials on compressed NFTs on our Helius blog, so please go look at that on your own time. But now we're gonna get to the code. All right, let's get started with today's project. So I'm going to assume that you have the course app installed and all the dependencies and tools you need to get started. If you don't, if you're new to Solana development, please reference video 2 in this course where I show you how to install all your dependencies and download the course app and everything you need to follow along with these projects. I'm going to assume you have everything, so I'm going to go ahead and continue. You should have your course app running on your local browser. I have mine on port 3000, like you can see on my screen, running on localhost port 3000. What I want you to do is go ahead and navigate to project 6 titled NFT Minter and click preview. And really, it's a really simple application because Helius APIs do a lot of the heavy lifting for us. All I'm going to do is go ahead and connect my wallet. I'm going to make sure that I'm actually on the test net. Again, you can actually use this on the main net, but for the purposes of this application, I'm going to go ahead and use it on the test net because I don't want to spend real money. So let me go ahead into my developer settings, activate testnet mode. You can do it just like that on your Phantom wallet. And I do have some DevNet Sol to have enough funding to sign for these transactions. It's important that you have some DevNet Sol. You can do that via your Solana CLI, or you can just go to a faucet website for DevNet Sol. So I'm going to go ahead and connect. Once I do, I'm able to click the mint button. I'm going to go ahead and do that. And sooner or later, once this transaction executes successfully, I'm going to actually have this NFT that I minted displayed on my screen, and I'm going to have the asset ID for me to reference on the Helius X-Ray Explorer. Now, I might be biased, but I actually think X-Ray is really, really useful for looking at compressed NFTs specifically. Throughout this course, I've been using the standard Solana Explorer. I think it's great, really good UI. The X-Ray Explorer is actually also really good, amazing UI, and I think the best for observing compressed NFTs. Okay, so again, pretty simple application. I just want to give you the experience of using Helius APIs. This will be the first time we're doing that in this course. And just to give you the impression of how easy it becomes to build these kinds of applications where you're interacting with on-chain data, creating on-chain data, and you can do it in just so seamlessly. Okay, so what you can do now is go ahead to the starter page of the Minter project. You just see some boilerplate. Within the folder, go ahead under Pages, under Minter, drag out the finished and the starter files just like I've done. And that's really all you need to do to get started. What we're gonna go ahead and do, like usual in these projects, if you've been following along with this video series, is we're gonna go ahead and delete this boilerplate code, just like that. Open up some curly brackets, and let's open up a return statement and some React fragments. so that the code stops screaming at us. Okay, first things first, like in any project, we're going to download, or not download, but we're going to import the dependencies necessary to build this app. So I'm going to do that by hand. I recommend you also do it by hand, especially if you're new to Solana development, or maybe just React development in general, just because when you do it by hand, that's how you really, get this information into your brain. I really believe that, and it's something that I've been honestly religiously talking about in every single project we've been doing so far. So if you've been following along with this course, forgive me for annoying you, but that's just my style. Okay, awesome. So just like that, you should be able to import those dependencies. If you're not able to, I recommend just running yarn in your terminal. 1 second. Yeah, just run yarn in your terminal, and you should be able to install everything just fine. I've obviously already installed everything. So yeah, okay. So next we're gonna look at some constant variables, NFT image URL and NFT external URL. Basically, these are variables that we're gonna provide our API request when we're creating our compressed NFT. These are just variables that we're gonna insert into the metadata of our compressed NFT. So we can just go ahead and declare that outside of our function. Mind you, you don't need to use these exact variables. They're just variables I chose to use, for my own testing and demo purposes. You can actually host any image on Google Drive and just copy that URL and use it for your own demo purposes if you want to try something new. But I'm just going to go ahead and do it like this. And feel free to copy this information. I'm just going to actually go ahead and not type this out by hand, because that would be take a little bit too much time and not super necessary, right? Okay, and for the external URL, I'm also just going to copy and paste that. Okay, so we've got our constant variables that we're going to use to populate our metadata for the compressed NFT we're going to create. Now we're going to set up our React state variables, I like to call them. Essentially, React lets you create stateful applications, meaning that you can, using React hooks like useState, declare and update state within your application throughout the lifetime of your app, right? As users interact with it and perform, certain actions on your app, certain variables are going to be updated over the life cycle of your app. And so these are the variables on our app that we are going to update throughout the life cycle of the app. So we're gonna declare one called API URL and a complementary function called set API URL. By convention, we preface it with set. We're gonna use a useState hook. Because it's a TypeScript app, we're gonna declare the type of this variable to string. And next we're gonna do NFT, set NFT, again, useState to string variable. And then NFT image, set NFT image. And that is also a string variable. So these are essentially just the URLs that point to the image or our NFT on chain. Okay, now the next two lines of code, if you've been following along this course, you should be extremely familiar with them by now. Essentially, they are variables that allow us to grab information from the wallet we've connected to our application. So when you saw me demo this project, you saw me connect my wallet to the app. Well, this is how our app retrieves certain information from our wallet. So we want the connection string, right? This is essentially the Solana cluster our wallet is connected to. So I was connected to the testnet, so that connection string would specify that I was connected to the testnet. It would have that URL. And this variable here, public key, is, you can imagine, it's the public key to the wallet that we've connected to our app. Okay, simple enough. Now, these next two functions that we're going to create, mint compressed NFT and fetch NFT, that's the meat of our application, right? That's the most interesting part of our application, where, I mean, semantically, we're going to create this function to mint a compressed NFT. It's going to be asynchronous. So in JavaScript, for functions that require us to interact with some external resource, we label them as asynchronous because they can take an undetermined amount of time, right, to finalize or to execute. Now this function takes one argument called event. I believe that's a DOM property. Now, if you're unfamiliar with these words, if you're unfamiliar with front-end development in JavaScript or React, maybe pause this video and search up some of these terms. They might help you as you continue to explore Solana front-end development. But essentially, this function here, event.preventDefault, allows us to prevent our React app from refreshing when this function is executed, essentially. Or better yet, when this function is called. Okay, fantastic. And that just creates a cleaner user experience. You don't always, you're not always going to want to use prevent your app from refreshing, but in some cases you do, and it's important to be aware of when and when you don't want to do that. Okay, so now we're going to get into the meat of the application. We are going to use the fetch function to essentially make our API call to the Helius mint compressed NFT API. So we're going to pass in two arguments essentially. One is going to be the API URL, and one is going to be an object, JSON object, describing the properties of our compressed NFT and what kind of API call we are making. But first, before we move forward, notice that we're not passing along URL string as our API URL in this fetch function. We are actually passing this API URL state property. And where are we getting that from? What is that initialized to? We've initialized it to an empty string. So if we explore it farther down our code, you'll see that I actually use another React hook called useEffect in order to programmatically update this API URL string whenever a user connects their wallet to our application, right? So let's actually go ahead and comment this out for me real quick. We're just gonna pause that, put that on pause, and we're gonna type out this code and I'm gonna explain it to you in more detail. So the React useEffect hook essentially allows us to run some code whenever some state changes, and we define, which state we're observing within these brackets, right? Within these array brackets. And you could really define multiple variables. In this example, I only define one, which is that connection variable. So essentially, when our app initially loads, right, this connection string is undefined, or I believe it's null, essentially. Essentially, it just has a no value. It's not populated with any value because there shouldn't be any wallets just automatically connected to our app. But once the user connects their wallet to our app, in that instance, this connection string is populated with the connection string that our wallet is connected to the Solana cluster. And so then it's updated. And when it's updated, this useEffect notices that, and then it executes the logic or the code we have within these curly brackets. And that code is essentially, we're gonna use that function we declared to update this API URL React variable. So set API URL, we're gonna open up those parentheses, and essentially we're gonna use what's called a ternary. So essentially, we're gonna specify a condition. So if the RPC endpoint of our connection variable includes the word devnet, right? So essentially saying, if user's wallet is connected to devnet, then using the question mark, we're going to say then we're going to populate this API URL variable with this connection string, essentially, the devnet connection string. Otherwise, we're going to populate the variable with this connection string. And maybe there are cleaner ways to do this, but this is one way to do it, and it gets the job done. And so this way, you can actually, from the user's perspective, you can actually use this app that we're creating on the mainnet, which requires real SOL, or on the devnet, just by flipping a switch on, whether your wallet is connected to the testnet or to the mainnet, essentially. So it kind of creates like a frictionless user experience, which is always something that we want to take into consideration and pay attention to when we're creating really any kind of front-end application, Web3 or not. Okay, so now that we've got that code and we have an understanding of what it does, let's go ahead and uncomment our mint compressed NFT function. And let's go ahead and pass in that API URL state variable. And then we'll open up some curly brackets. And we're going to go ahead and type out this JSON object, and I'm going to walk you through it as we do in case you are unfamiliar with this kind of code. So essentially, we are making what's called a post request, right? We want to create some resource on this external entity that we're interacting with, the external entity being the Solana blockchain. So we are posting something, right? We're creating something. So this is a post request. We're going to provide some headers. This is actually pretty standard. This is pretty standard stuff, not specific to Solana or Web3 applications at all. And now we're going to provide the body. We're going to use this JSON stringify method. We're going to open up those parentheses and then another set of curly brackets to specify another JSON object. And for this JSON RPC, we're just going to put 2.0. That's not super important. You don't need to pay attention to that so much. This ID parameter is also kind of arbitrary. You can really give it any kind of ID you want. I just put Helius front-end course. Now the method is important. You must, in order to use the mint compressed NFT API, you must type mint compressed NFT, just like I did right now in camel case. And the params is another parameter you want to pay careful attention to, because this is actually going to be the metadata. This is going to define the metadata of your compressed NFT that we're creating. So you can define the name of your NFT. I'm just going to give it Nathan's super awesome NFT. You can really give it any name you want. It doesn't matter so much. We're going to give that NFT a symbol. So Nathan's super awesome NFT, just like that. And then we have to specify the owner of this NFT. So your answer to this question might depend on your type of application, how it works, the use case of your compressed NFT. But for simplicity's sake, I'm just going to type in the public key variable that we grabbed from my user's wallet. So that way, when they mint this NFT, it's actually their NFT and they should be able to see it in their wallet. And if I actually go to my NFTs, you can see the NFT that I minted just previously when I demoed the application. Okay, next is the description of our NFT. And again, arbitrary value. I recommend keeping it, relatively concise. Nathan's super awesome NFT that he owns. And let's go ahead and give it some attributes. And we're gonna do trait type. I'm gonna give it an attribute of cool factor, and I'm gonna give my NFT a cool factor of amazing, right? Or level 1000, whatever it is that you wanna do. Again, this is also kind of just an arbitrary parameter that you can give your NFT. But, you know, if you're creative, you can imagine that this attributes parameter, you can get creative with it if you're trying to create compressed NFTs for video games, or, you know, unique use cases beyond just PFP images. Next, we're going to provide the URL to the image. So I'm going to go ahead and provide my constant variable there. And then the external URL. And the seller fee basis points. Okay, so this also is worth paying attention to. Essentially, the seller fee basis points determines how much of the revenue you, as the original creator and the owner of this compressed NFT, will get on each secondary sale of the NFT, right? And so here I put 6,900, which translates to 69% essentially. So this means that, you know, if I give this NFT to you and you sell it, and your friend sells it, and your friend's friend sells it, on each of those sales, I, being the original creator of this NFT, will receive 69% of the amounts of each of those subsequent sales. So, you know, important, that number is important, and something you want to pay attention to and pay mind to. Okay, fantastic. So that's essentially, you know, very high level way of really creating a compressed NFT on the Solana blockchain using Helius APIs. If you have experience, you know, trying to create compressed NFTs using other tools, you might have run into some difficulty because they don't always work. Sometimes they're unreliable, and maybe just a little bit overly complicated. But, you know, I personally like to use Helius products for this reason, just because as a developer, it makes my life so much easier. Not to shill, but I mean, that's just really my personal opinion as a software developer. Okay, fantastic. So here, we're essentially extrapolating the results from this API call that we're making, and we're just gonna log that to the console for development purposes. And what we're gonna do is we're gonna say if this result exists, right? And it would only exist, if this result does not exist, which de facto means this API call failed for some reason, then we're going to throw an error on the UI saying request failed, and we're doing that with the Toastify library, which I love for throwing user-friendly on-screen notifications. And then we're going to, actually, let's go ahead and console log that error as well. This might be useful for you in case your app doesn't work out for you. Yeah. Let's try, actually, let's create some try catch blocks. That would be better. So we're going to extrapolate that results. And then we are going to try to catch that error in a catch block. Let me just copy and paste that code there. And we're gonna pass in these values. That's actually a slightly better way of doing that. And then once we do that, essentially we're going to, this assumes that our API call succeeded, then we are going to update our NFT state variable with the asset ID of the NFT we just created. And we're going to call this fetch NFT function that we have not created yet. So actually, let's go ahead and declare that real quick using ES6 syntax, arrow function syntax. So we're going to pass in 2 arguments, asset ID of type string, and again, the event just like that. And we're going to say fetch NFT result.asset ID and that event. Okay, fantastic. So just like that, we created our mint compressed NFT function, which again uses the Helius mint compressed NFT API in order to make a call to create a compressed NFT on the Solana blockchain. Now, before we move on, I actually should have done this earlier, so I apologize for leaving you hanging. What I want you to do, right? So in order to get these APIs, and these are my API keys. Now, please, I'm showing this to you because this is just a demo and it actually doesn't matter that I show you my API keys, because I mean, there's nothing you can do with them. But I highly recommend, for those of you that are, maybe new to programming whatsoever, never expose your API keys to any service, and especially to your Helius account, because if someone gets a hold of your API key, they can use that resource to essentially spam your account on your dime, and that is never good. So please be responsible and do not do what I'm doing now. Okay, so what I want you to do is go to helius.dev, click start for free. You do not have to pay anything to follow along with this course, and it's really as simple as connecting your wallet to the Helius blockchain, not to the Helius blockchain, but to the Helius dashboard, just like I did right now. You can go ahead and click on API keys, and here you'll be able to reference your API key, or you can also just go ahead and copy and paste this string URL and insert that there for the mainnet, and your devnet URL, and insert that in place of my devnet URL. You can actually, it might be even better to create some constant variables. So devnet URL. Actually, the real best way to do this in a production application is to create a .env variable. And I'll go ahead and do that with you right now. So you can create a .env variable. Next, public devnet URL. Set that equal to, and let's do general purpose devnet URL. Let's do that there. And then next, public mainnet URL, and set that equal to this string. And essentially, you should be able to, just like that, say process.env.next public devnet URL. And am I getting some argument of type string undefined is not assignable to type parameter? Undefined is not assignable to type string action. There we go. So I just kind of, this is maybe a little bit hacky, but I kind of use the bang operator to tell TypeScript this is equal to a string value, essentially. env.next public mainnet URL. Okay, so that is actually the better way to use your API keys in your front-end application. So I highly recommend you go that route because this is just a simple demo app. It's not super important, and obviously because to help you follow along with this application, I'm kind of abstracting some of these best practices to make it a little bit easier for you to follow along. So please do what you may. For simplicity's sake, I'm gonna go ahead and leave my connection strings like so, and we can go ahead and finish this this fetch NFT function. It's actually not that large, so let's go ahead and get to that. So again, we want to prevent our React app from refreshing. We're going to create another response variable and set it equal to the result of this API call. We're going to pass in that API URL and another object. Again, this is going to be a post method, and the headers we're going to pass in are going to be a content type application/JSON. And for the more interesting part of our API call, we're going to create this body. Why is it screaming at me? Okay, let's see why. Oh, right, because this has to be a JSON stringify item, just like that. Okay, fantastic. So use JSON.stringify, that method, open up those parentheses, and then a set of curly brackets within them. And then we're gonna type in that JSON RPC 2.0, standard stuff, give it an ID. So we can just give it fetch CNFT. Really, you can give it any ID you want. Now the method, again, the method is important, right? What method are we using? We're using the get asset method. We're essentially using the Helius DAS API to fetch the compressed NFT that we just created on chain, right? So when I demoed the app, I minted a compressed NFT, and then you saw the compressed NFT display on our application right in front of us after we minted it. That's why we're able to display it on screen, because we're fetching it from the blockchain, and then we're parsing into metadata in order to set that URL image on our app. Okay, so using the get asset method and the params, really, so what asset do we want to fetch? Well, we're just going to pass in the asset ID of the NFT that we created inside this ID parameter. Really simple stuff, super straightforward. And then after that, we're just going to go ahead and set those state variables. So go ahead and with me, create those try catch blocks one more time. And go ahead and within the try block, we're going to extrapolate that result value from the API call that we just created. And assuming all goes well, then we're going to go ahead and update our NFT image state variable that we declared at the top of our app with the NFT image URL of the NFT we created. And we do that by saying result.content.links.image. And if you want, actually, I recommend let me just say, logging this information to your developer console in your browser and just parsing through that object, essentially, that response object, and then the NFT object, just to get familiar with the specific information you're looking for and that you want to use in your application. Just to familiarize yourself with the structure of those resources, of those objects. Okay, awesome. Now, if this fails, of course, we are going to throw an error on the UI. That's a simple error message, and then you can just throw the error just like so. Okay, fantastic. So simple enough. This design pattern here is something that you should be familiar with if you've been following along with this video series. Essentially, I like to create simple data structures for, repetitive UI elements. In case you wanted to add another UI element, it's actually just a matter of populating this array with another object. It makes your life as a front-end developer a little bit easier, makes your code a little bit cleaner. And it's just a general design pattern that's pretty popular when creating front-end applications, especially React applications in my experience. Okay, so just like that, we've pretty much created all the business logic. It wasn't too much because, again, we're using Helius products to abstract a lot of the glass chewing from our code. Now we're going to create the UI. It's a pretty straightforward UI. And so go ahead and follow along with me. Again, I recommend you type this all out by hand just to get in the habit of, what is it like to write HTML and Tailwind CSS, which is a fantastic styling framework. Okay, so right now we're setting the width of our UI elements, depending on the screen size. Just like that, okay. And now within that main tag, we're going to open up a form tag. And this is going to have essentially 2 divs. So we're going to create that 1 div and 2 divs. And we can determine just by kind of reading the code that this div is kind of like a header. And this div is, that is essentially that the ID of the compressed NFT that we just recently created. So we can type compressed NFT ID. Okay, pretty simple. So let's go ahead and create those 2 items. So within that div, we're going to give it some styling. We're going to say flex justify between items center. And we're going to give this label some styling. And you can really title this app whatever you want. Obviously, that doesn't matter too much. Now within this button, because this button is within a form tag, we're not gonna tie it to a function specifically. We're just gonna give it a type submit. We're gonna give it some styling. And because this string of styling is particularly long, I'm just gonna go ahead and copy and paste that to make our lives a little bit easier and focus on the good stuff of this application. We are gonna give it some disabled conditions. We're going to say if the public key is not available or if the connection string is not available, then this button is disabled. Essentially what we're saying is if the user's wallet isn't connected to our app, then you shouldn't be able to execute this function. So we're going to go ahead and disable that button. Pretty simple. Now within that form tag, what I want you to do is open up that form tag and you're going to provide 2 items. First, a class name for some styling. And if you'd like, you can go ahead, I'll let you copy this styling as well so we can focus more on this on submit tag, which essentially we're using ES6 syntax to declare a function which calls, essentially an anonymous function which calls the mint compressed API function we created earlier, passing in that event property essentially that we use to prevent our React state from refreshing. And so, in case you're new to HTML or, form elements in HTML, we are declaring a button within a form element, and because it's type submit, when this button is clicked, it's going to execute the function that this form element is associated with. Okay, fantastic. So now we can go ahead and move on to the next UI element, and we're gonna go ahead and give it that styling. Oops, misspelled that. We're gonna give it some spacing from the top and a custom background color, just like so. We're gonna give it some border information and some padding. Okay, and so what is this? Well, essentially we're gonna create an unordered list of items. And within that unordered list, we're gonna insert logic into our UI, into our JSX or TSX. That's gonna say that output array we declared, well, we're gonna map over it. So we're gonna iterate over each item in that array. And for each item, we're going to extrapolate that title value, that dependency value, and we're going to extrapolate that href value, and then we're going to create like an index value for each item we iterate over in that outputs array. And then we're going to open up a set of, we're going to use an arrow function and then open up a set of parentheses to implicitly return some kind of UI elements, and that's going to be a list item. And because we are programmatically creating these list items, React says that we have to provide a key, so some unique value to distinguish each list item from each other. And so we're gonna just pass in the title value as the key. So in that case, make sure to keep each title value unique in case you want to add, more objects to this array to render on screen. And then we're going to use string interpolation in order to programmatically update the CSS of these, to conditionally update the CSS of these list item elements. So we do that by opening a set of curly brackets and then backticks, and then we can type in some general CSS information. And then use that string interpolation to say, well, if this isn't the first item in the array, then we also want to give it some margin spacing from the top, from the item above it, essentially. Now within this list item, we're going to provide a p tag with some letter spacing. And this is just going to be the title, essentially. And right below that, we're going to open up another set of curly brackets to put some conditional logic saying if the dependency does not, or if the dependency is provided within the given, object that we're looping over. So if there is a dependency, then we're going to insert this a tag. And this a tag is going to contain a pointer to the URL and some additional information that essentially says when the user clicks on this a tag, the app is going to open this link in another tab, essentially. And then we're going to give it some styling information, a custom color, because why not? Some hover states information, because that just makes for a better user experience, so that the user knows, receives some kind of indicator that they are in fact going to interact with this item. And then we are essentially just grabbing that dependency. We're going to slice it so it's not as long. because we don't need to show the whole thing. You don't need to do that, but I prefer to do that. And then we're going to insert that external icon just to make our UI a little bit more, pretty and a little bit more, I guess, interpretable. And so finally, for the last UI element that we're creating, this is kind of, it's actually maybe the simplest part of our UI, but it's probably the most interesting or eye-catching part of our UI on screen. It's essentially our NFT image that we're going to render. So we're going to provide some spacing from the top. Again, a custom background color that you can declare in CSS using brackets. We're going to give it some border information. And then a custom height value. Just like that, fantastic. Okay. Again, we're gonna do some conditional rendering, and that requires us to open up some curly brackets, right? Whenever we wanna insert logic into our TSX, we have to use those curly brackets. And so we're saying if the NFT image exists, so we successfully fetched this NFT, this compressed NFT we created on the blockchain, right? So, and then which means that we successfully extrapolated this result value from our response and updated this NFT image state variable. So if that exists, and actually it might be better to declare that as null, right? Because in this case, this item is initialized to null, so it would be false, right? So if it exists, then we're going to render an image. And we're going to give it the width property of 300, height of, again, 300, so it's just going to be a square. The source is going to be of NFT image, set it equal to that state variable, and then we're going to give it a little bit of styling so it doesn't look ugly. Of border gray and 500. Okay, awesome. Now what happens if this NFT image isn't populated, which means our DAS API call went wrong for whatever reason? We're just going to provide a simple message saying NFT image goes here, right? You could maybe, I challenge you to think of something a little bit more creative than that, than just a simple string of text. But for demo purposes, I think that suffices. So that is our code. That is all of our business logic and all of our UI code. If you navigate back to your local host, your code should look something like mine. Okay, so it's not exactly perfect. I must have mistyped on my CSS somewhere. Let's see if I can find it. Well, hopefully yours looks a little bit better than mine, but I'm sure the logic still works. So I'm gonna go ahead and try that out right now and mint that NFT, and awesome. The NFT successfully minted. We can see that on the X-ray. And just like that, it seems like the app works the way it's supposed to. There we go. So yeah, my app was probably just running a little bit slow, but there's my asset ID and the image for my compressed NFT. And again, if I look at this information inside of my wallet, then I should be able to see that I have 3, right? So I minted one at the beginning, another one just right now, and another one just again right now. Thanks for watching this video. Please feel free to connect with me on X, to connect with Helius on Discord, or to learn more about us on our website. I look forward to seeing you in the next video. Peace out.